Alright, this is a walkthrough of lab number 12 in case you can't get this Java lab to work. I do know that they are kind of finicky, so if you can't get the lab to work, then you should be watching this, and I'm going to essentially do the lab, and you can jot down your own observations from what I've done. First thing we're going to do is we're going to pop open the simulation, and here I have the simulation, and you can kind of see a wheel, a ladybug, and a brake, and we can manipulate this wheel if I were to click and drag on it. First thing I'm supposed to do is I'm supposed to grab it and set it spinning. What's going to happen, and then we're going to release the wheel and pay attention to Ladybug's velocity vector and her acceleration vector. Then we're going to pay attention to the angular speed, and we're going to use the brake to stop the wheel. So let me go ahead and do that. So I'm about to click and drag on the wheel. You can kind of see that happening. I'll give it a little bit, speed this thing up a little bit here, and pay attention to the velocity and acceleration vector. Now I'm going to go ahead and use the brake, so make your observations as I do this. Now we're supposed to click on the torque tab, and what we're supposed to do is we're supposed to set the force equal to 2 and the radius down to 0. Click go and make your observations. Pay attention to the torque on the wheel as I do this. So the force is set to 2, and I'm going to drag this thing down to 0, and I'm going to hit the go button. You can kind of see what's happening, and you're sitting there puzzled because nothing is happening. Kind of makes sense. The net torque is right here, and I see a 0, and torque's what causes this thing to accelerate. So I can click on the stop button. Now we're supposed to set the radius equal to 4 and hit the go button. Pay attention to the net torque, velocity, acceleration. Where does the force come from? What type of force is it? And what's eventually going to happen to the ladybug? So I'm going to go ahead and slide this guy up to 4 here, and now I can click on the go button, and now what we can kind of see is we have the net torque that's right here. Might want to jot that guy down.
Whoa.
And the ladybug went off, so I'm going to hit the stop button, and I'm going to reset all these guys. So I've reset it all. I'm going to set the force back to 2, and I'm going to hit start, wait about 2 seconds, and then I'm going to set the brake force to 1 Newton. So what we can do is we can set the force to 2, the radius is now at 4, and I'm going to hit the go button, and then I'm going to set the brake force right over here. So hit the go, and I'll set that to 1 Newton, and you can kind of see what happened is here I have my force, here I have my brake force. Now I have a different net torque, and I don't know about you, but it seems like this thing is not speeding up nearly as fast. Now we're supposed to go ahead and click on the angular momentum tab. We're supposed to set the angular speed and the mass of the disk, and we're going to record rotational mass and angular momentum of the system, and then we're going to mess around with the platform mass. As we mess around with the platform mass, pay attention to what happens to the angular speed, and you're going to record angular velocity, rotational mass, and angular momentum in this column as I go up and down with it. Then you're going to answer, was angular momentum conserved? And this guy is for you all to do. So let me click on the angular momentum tab. I'm going to set that guy to 45, and we're supposed to set the platform mass to 0.1, and we can hit the go button. Now you can go ahead and record the rotational mass, and you can 45. There we go. Now you can record the platform mass, and you can record the angular momentum of the system right over here. And I'm just going to work my way up and down in platform mass. So you can record that value. You can record this value. And you can record that one. I know it said 0.24, but we'll be risky and go to 0.25. I'll go down right over here, and I'm going to take this guy down right here. So that should be enough for you to complete the table in the lab.